This is my daddy's station. I'm Pooh, classic radio like you always wished it could be. 101.1 FM, eager.
101.1 FM is owned and operated by the Independent Foundation Trust as a non-profit community service.
This is the Voice of Freedom. You're listening to the Worldwide Freedom Radio Network. You're listening to the Hour of the Time. I'm William Cooper. Ladies and gentlemen, today I'm going to prove William Jefferson Clinton right once again when he said that William Cooper is the most dangerous radio host in America. We're going to have fun today. At least I am. I don't know about you. I think some people out there, people who work for the United States government and for NASA, are going to be squirming in their seats. They're not going to like this broadcast at all. Every Friday, ladies and gentlemen, is going to be Space Day. Every Friday from now on is going to be Space Day. We're going to talk about NASA. We're going to talk about UFOs. We're going to talk about the Pathfinder mission to Mars. We're going to talk about the Apollo space program. We're going to talk about a lot of things every single Friday from here on out. So spread the word. This is going to be the most interesting radio broadcast in the world every single Friday right here. I am not going to baffle you with bullshit like Art Bell does. I'm not going to lie to you like all of the people who talk about UFOs and the space program and everything else connected with this stuff like most everyone else does. Not everyone does, but most of them are and continue to do it. Today, I'm going to be reading to you directly out of Renee's book called NASA Moon to America. And I think these are a couple of chapters that I never did before. We have this book available, by the way, if you'd like to order it from us. It's $25, plus I think $3 shipping and handling, which makes it $28 post-paid. If you want to order this, it is the even though I was talking about this stuff, and other people too, not just me. In fact, some people had revealed some of the fake photographs and some of the false science that NASA has been giving us long before I came along. Then I came along and on my own discovered that most of the photographs were fake and much of the videotape. And I began talking about it, and then I discovered those who had come before me, and then later I discovered Renee. And but Renee, you know, rather than just talk about it, has written a book that is just it's hilarious, ladies and gentlemen. It is absolutely hilarious. No wonder NASA is so upset with this book. It literally, it calls them a liar right to their face. And when you have investigated these things like I have and like Renee has and like many other people have and find out that NASA's lying to us, you'll call them a liar too, because quite frankly, NASA has lied to the American people for many years. I know why they did it. I didn't know why at the time. I didn't even know why when I first discovered that some of the photographs were fake and the videotape was fake. I had to study this stuff for a long time and put it in context with what's happening in the world. What is the agenda with all of this? And then I came up with the answer. But I'm not going to talk about the answer tonight. We'll talk about that on some future Friday. But we've got to talk about this, folks. You've got to get this book. It's called NASA Mooned America by Renee. And you can order it from us for $28 post-paid. Make your check or money order payable to Harvest and send it to Harvest at P.O. Box 2470, Pine Top, Arizona 85935. That's $28 post-paid. Send it to Harvest. Make your check or money order payable to Harvest at P.O. Box 2470, Pine Top, Arizona 85935. Now, we just didn't come up with this book, folks. We've been selling it for a long time. But our purpose is not to get on the air and sell things all the time. It's to impart information. But imparting the information in this book, you might decide that you want to have a copy. And we have carried Renee's book for several years now. And in fact, until we came along and carried his book, Renee was in quite a bit of trouble financial-wise. He just, nobody would touch this book. Just like when my book first came out, nobody would touch it with a 10-foot pole. Now everybody wants Renee's book. And rightfully so. Everybody should have a copy. I'm going to be talking about heat and cold today, ladies and gentlemen, right out of NASA Mooned America. The single greatest misconception we have about space is that it is cold. NASA tells us that the temperature in space, in this great vacuum out there, is pretty close to, if not right at, absolute zero. How can that be? NASA is a great science machine. But they've never done a single thing to dispel this great myth. Instead, they have promulgated it and, in fact, just blatantly lied about it. And it's for the advantage of the socialist agenda. Even though one definition of cold is the absence of heat, space is an absolute exception to this rule, ladies and gentlemen. The absence of heat does not produce cold in space. It produces a vacuum, nothing. It's neither hot nor cold. As a kid reading thousands of science fiction stories, I would find a repeated situation similar to this. Now, this is Renee talking in his book. It's not me talking, although I agree 100% with everything that you're going to hear. I continue. Jay Vordak was in serious trouble. He had been able to extract the Crintac ray generator from the vault on the Volsa ship, but the vault guard robot had smashed his suit heater in the last seconds of the fight. It was as dead as the robot. The ray would save his people from being enslaved by the Volsa only if in the next few minutes he could reach his ship hidden amongst the huge boulders on this barren, rocky asteroid. He could feel the bone-numbing cold of space rapidly sucking the heat from his body. Until I began to write this book, I never realized that space is neither cold nor hot. Only matter can have these attributes, and space is the absence of matter. You see, science claims that heat is a measurement of molecular activity. Since there are very few atoms or molecules to be agitated in space, space can neither be hot nor cold. As a near perfect vacuum, it is at the same time the greatest insulator and the best heat sink in the universe. It exists unaffected next to the incredibly hot surfaces of stars. It remains just as completely unaffected near the absolute zero temperatures found on comets traveling through interstellar space. Now I'm going to break here because some of you may not understand what I just said, or what Renee just wrote, I should say. I'm reading what Renee wrote. He said it remains unaffected next to the incredibly hot surface of stars, and you all understand that stars are incredibly hot. Then he says it remains just as completely unaffected near the absolute zero temperatures found on comets. And some of you may be confused by that. If space cannot have a temperature, how can a comet be near absolute zero temperature? Well, it's very simple, folks. A comet is a huge ball of ice. Scientists have determined, and they have proven to my satisfaction, that comets are huge balls of ice traveling through space. So that's what he's talking about here. I continue. Before we can understand what happens on a spaceship or to a space suit, we need to understand a bit about heat. This section is a little refresher course for those who once knew a lot about heat, and a beginner's course for those who only know that ice is cold and a fire is hot. And that's probably what most people know, even though they may have learned more than that in school. Temperature is the measurement of the molecular activity in a mass, the sensible heat energy in a substance. Now make sure you understand what I'm talking about here. Sensible heat is measured in degrees by various temperature scales. Despite an act of Congress many years ago that demanded we adopt the metric system and use the Celsius temperature scale, most Americans still subconsciously think in terms of Fahrenheit temperatures and also in the English system of weights and measures. We cling to it, not because it is superior, but because we were brought up using it, and we can instantly visualize its various units without any conversions or any problems. We know it. We know an ounce of weight, a mile of distance, and a degree of Fahrenheit temperature. We Americans do not yet think in terms of grams, kilometers, nor degrees Celsius. The Fahrenheit scale places the freezing point of water at 32 degrees and the boiling point at 212. Remember those numbers. Water at 32 degrees is freezing, that's Fahrenheit, and the boiling point of water in Fahrenheit is 212 degrees. Now, this scale is awkward and admittedly hard to calculate with, but we've used it from our earliest schooling, and in this case, familiarity breeds ease of use. The Celsius scale calls the freezing point of water 0 and the boiling point 100. Much simpler for those brought up using it, but confusing to those of us who weren't. There's also the Kelvin scale, which uses the Celsius degree and calls minus 273 degrees absolute zero. That's minus 273 degrees Celsius, absolute zero on the Kelvin scale. Now, for the purposes of easy reading and comprehension, I shall use degrees Fahrenheit for our discussion. However, for heat calculations concerning radiant energy, it is necessary to use the Kelvin scale. And he has a table here which shows a short range of everyday Fahrenheit temperatures and their Celsius and Kelvin equivalents. And when you get the book, if you get confused, you can refer to this. Now, my purpose here is not to educate you on how to convert Fahrenheit to Celsius to Kelvin or backwards or in between in any of these. It's just merely to read this chapter and possibly another one to you and acquaint you with some deceptions that are being run. If you have any concerns about these conversions, then you can just write down what you hear, run down to your library, or you can order this book and refer to this conversion scale. The definition, ladies and gentlemen, of heat conduction is the process by which molecules transfer heat energy to another molecule. All materials conduct heat, but metals are much better heat conductors than nonmetals. Liquids are much better conductors than gases. Flowing substances conduct heat much better than their stationary counterparts. Most organic substances are poor conductors of heat, and a vacuum is the worst heat conductor of all. Insulation is defined as any material that is a poor conductor of heat. The best insulating materials only slow the conduction of heat. A man in a modern firefighter's suit can walk bravely into the flames surrounding a burning oil well and survive. However, he will survive only as long as hoses keep spraying him with cooling water to remove the heat. Should the water pump fail, he has only split seconds, and maybe not even that long, depending upon the temperature of the fire, before he is parboiled, and minutes before he is cremated, despite whatever suit or protective gear he is wearing. A vacuum is the best insulator because it is composed of nothing. Being nothing, it has few molecules or atoms to agitate, and therefore cannot transfer heat by conduction or convection. The most well-known application of this fact is the Dewar flask used in cryogenic work, or its household relative, the common glass thermos bottle. The principle, ladies and gentlemen, of a thermos is simple. The inner section is composed of a narrow-necked, ultra-thin glass-walled bottle fixed within a slightly larger, ultra-thin glass-walled bottle. The bottles are hermetically sealed together after the air between their adjacent walls is evacuated by vacuum pump. To reduce the heat loss even further, the outer and inner surfaces are mirrored. This stops some of the radiant heat loss because it is reflected back and forth by the mirrors. A cork is used as a stopper in the opening because in addition to the ease with which it compresses to make a tight seal, cork is also a very good insulator. In fact, cork was one of the best heat insulating materials before space-age materials became available. This entire assembly was usually placed in a steel case and covered with a removable cup that threaded onto the main case, and almost everybody at one time or another has carried a thermos bottle containing soup, hot coffee, or ice-cold tea, or ice-cold Kool-Aid or water to school or to college or to work for their lunch. A good thermos, ladies and gentlemen, can hold either boiling hot beverages or ice-cold drinks and can almost maintain the starting temperature for hours depending upon the ambient temperature of the environment. Got that so far? Radiant heat is defined as heat energy transferred by an electromagnetic wave. Let me read that again for you. Radiant heat is heat energy transferred by an electromagnetic wave. Now, the only way heat energy can be transferred through a vacuum is by radiation. The Stefan-Boltzmann law is used to calculate the quantity of heat being radiated or received by a substance. The radiant heat transmitted from a unit area of surface is proportional to and thereby mostly dependent on the fourth power of the absolute Kelvin temperature of that surface. The words fourth power sound complicated, but they simply mean multiplying a number by itself 4 times. For example, the fourth power of 2 is 2 times 2 times 2 times 2, which equals 16. You see, it's not very complicated at all. The fourth power of 3 is 81, the result of 3 times 3 times 3 times 3. The number 3 is only 1.5 times greater than 2. However, if we divide the fourth power of 3 by the fourth power of 2, we found it is 5 times as great. Therefore, a body radiating heat at 3 degrees Kelvin radiates 5 times as much heat as a body at 2 degrees Kelvin. Now, this ratio drops quickly as the numbers increase, and this ratio is why we must use Kelvin when talking about radiant heat. The heat emitted is also dependent upon the coefficient of emissivity. This is a number which ranges from 0 to 1. You see, a perfect emitter would be 1, and the perfect mirror would be 0 because it would reflect all the heat that hit it. It doesn't matter if the surface is emitting or absorbing radiant heat, the coefficient, ladies and gentlemen, is the same. A constant called Stefan's constant is also necessary to produce numerically correct answers. The Stefan-Boltzmann formula produces numerical answers in watts, which then can be converted to calories, a heat unit that we're more familiar with, especially you women who are always dieting, by multiplying by the number 860. Now here we go. The sun's surface temperature is estimated at 6,000 degrees Kelvin. The radiant energy at this extremely high temperature is truly awesome, ladies and gentlemen. By using Stefan-Boltzmann's law, we find that 73,487,090 watts per square meter is transmitted into space. After it has traveled 93 million miles to the Earth, this figure has been reduced to an average of 1,353 watts per square meter above the atmosphere. The definition of boiling is the vaporizing of a liquid by the addition of heat. Now, when we boil any liquid, we produce a vapor of that liquid. In addition to the sensible heat, each gram of vapor carries with it a much greater amount of non-sensible heat, which is called the heat of vaporization. If the vapor is physically removed from the area, the remaining liquid becomes cooler. The temperature at which a liquid boils is also varied to a great degree by the pressure. On top of a mountain, where the atmospheric pressure is less, water boils at much lower temperatures. The freezing point of a liquid is also affected by pressure in a similar manner, but to a much lesser degree. Put a tumbler of water in a vacuum chamber in which the vacuum is being continually increased, and it will start to boil without the addition of heat. In fact, if you had a thermometer in the tumbler, you would see the temperature of the remaining liquid drop as the vapor was pumped out. At a low enough pressure or a high enough vacuum, you would also see some of the water turning into ice at the same time the rest was boiling. In effect, the remaining water is being refrigerated by the heat energy it is losing. Once boiling commences, the pressure will drop much more slowly than in the beginning. The lower the pressure, the harder the pump must work. Since each volume of water vapor is 1,200 times greater than the water so vaporized, the pump must evacuate that much more volume from the vacuum chamber. If you didn't realize that you were removing heat by extracting the vapor, you might conclude erroneously that a vacuum is inherently cold. Indeed, science fiction books, science fiction movies, and television space operas have led us to exactly that conclusion. But this, ladies and gentlemen, is not true. If space was as cold as we have been led to believe, then any surface area of a spaceship away from the heated sections could become dangerously weak and susceptible to failure. Too much cold, like too much heat, can seriously affect the structural integrity of most materials. During both the Arctic and the Antarctic, winter temperatures can drop below 60 degrees Fahrenheit. At that temperature, rubber loses much of its flexibility and metals become dangerously brittle. But this temperature, minus 51 degrees centigrade, or 222 degrees Kelvin, is relatively hot compared to absolute zero at minus 273 degrees centigrade. Now, refrigeration is defined as a process which cools a substance by the physical removal of heat. Mechanical refrigeration uses a lot of power. Heavy motors, pumps, and a refrigerant to pump heat out of a well-insulated container. The refrigerant must be able to store the heat it absorbs from the container and must also be capable of releasing that heat in the heat exchanger. Some type of pump is needed to remove the hot refrigerant from the container to the heat exchanger and then bring the cool refrigerant back again. This heat exchanger is vital because it transfers the heat to a heat sink, which on Earth is either the air of our atmosphere or sometimes the water of a pond, river, or ocean. Without a place to dump the heat, there would be no refrigeration or air conditioning as we know them. The definition of explosive freezing is the rapid decompression of a liquid or a gas. In a CO2 fire extinguisher, carbon dioxide, which is a colorless gas, is stored under high pressure in a liquid state. When we pull the trigger, the liquid released from the pressure rushes out into the air, instantly exploding into a fine spray of extremely cold and frozen particles called dry ice, which soon, very quickly evaporates and becomes carbon dioxide gas. The latent heat is lost because of the tremendous change or drop in pressure. Fuel cells are defined as a generator that combines a fuel and oxygen and primarily produces DC electricity and water instead of heat. These units, folks, are similar to batteries. However, unlike a battery, which uses a chemical change to store electrical energy, a fuel cell uses a chemical process to generate relatively small amounts of electricity. Also, unlike batteries, the fuel or chemicals are not stored internally, but are fed in as the electricity is needed. Spontaneous combustion is defined as a process where oxygen, or oxidation, I should say. Let me do this again so nobody is confused. Spontaneous combustion is defined as a process where oxidation creates more heat than is being emitted. Whenever more heat is generated in a closed system, like a house, a car, etc., than can be given off, the temperature rises. As you will see, a spaceship or spacesuit is no different. In summation, if a vacuum was inherently cold, we could air condition and refrigerate simply by putting a vacuum chamber around the unit's radiator and then pulling a vacuum on it. How about that, folks? Isn't that pretty simple? But NASA tells us, ladies and gentlemen, NASA tells us that space is cold. So cold they tell us that the temperature in space actually approaches absolute zero. And that, folks, just ain't true. If a vacuum, ladies and gentlemen, creates temperatures approaching absolute zero, how does a thermos bottle, which uses a vacuum, keep your coffee hot? Tell me that. In order to have a measurement of heat or cold, ladies and gentlemen, you must have molecular action or inaction. Wow. Bet you didn't think you'd ever hear anything like this, but that's why William Jefferson Clinton calls me, William Cooper, the most dangerous radio host in America, because you hear things like this all the time on this broadcast. You hear the truth, ladies and gentlemen, that no one else will tell you. I know many of you are scratching your heads and saying, why would NASA lie to us? What have they to gain? Why did they do it? Well, folks, like I said, we'll cover the answer to those questions on a later broadcast of the Hour of the Time, one Friday in the future. And don't miss any of these Fridays, because you might miss the answer to those questions, because I'm going to give them to you. I know exactly why they did it. I know exactly why the whole scam was perpetrated. I know why they faked the photographs. I know why they faked the videos. I know why. When Neil Armstrong says that he was the first man to step foot on the moon, he lied. Neil Armstrong has never been farther away from this earth than 300 miles in his whole life, ladies and gentlemen, and neither has anyone else. We know that. Now, there may have been someone who may have gone to the moon somehow, but they didn't do it with anything that NASA has built or flown or told us that they did it with or in. And none of the men who claim that they went to the moon during the NASA's Apollo space program ever actually, if you want to know the truth, left the highest layers of the Earth's atmosphere, which, by the way, is known as the thermosphere. You see, they couldn't have even gone through it. And if they had, they could never have gone through the Van Allen radiation belt. But if they had, they never could have survived the unbelievable and tremendous radiation in space. But we won't go into those things tonight. We're talking about temperature. But before we get into the second half of this broadcast, I want to remind you all that we have 12 back issues of Veritas available, and we want to get rid of them. We want to get them out of stock. I already have my personal copy of all of these, and in fact, 2 or 3, I think. But we have 12 back issues in stock. Now, in all fairness, I must tell you that number 1 is a reprint. The back issue that we have in stock of issue number 1 is a reprint. It does not have the blue banner on the front page of the headline, nor the blue stripe at the bottom of the front page. And therefore, it is not a collector's item. All of the other issues which we have as back issues for sale are the original first edition, first printing, and they are collector's items. So we have issue 1 and 2, and issues 5 through 14, 12 in all. Normally, ladies and gentlemen, they're $5 a piece, which means that these normally would cost you $60. We're going to let you have all 12 of them while they last for only $25. All 12 while they last for only $25. Post-paid, delivered to your door. Can't beat that. Can't beat that at all, ladies and gentlemen. The information in these issues of Veritas is astounding and will never be out of importance or beyond your ability to use that information. It is still current and up to date, and still is something that you need to know. So all 12 back issues, instead of paying $60 for them plus postage and handling, you get them all for $25 post-paid, delivered to your door. Take advantage of it. Make check or money order payable to Harvest and send it to Harvest at P.O. Box 2470, Pine Top, Arizona 85935. That's Harvest, P.O. Box 2470, Pine Top, Arizona 85935. And while you're at it, if you'd like to pick up a copy of Renee's book, NASA Mooned America, send us $28 and tell us that you want NASA Mooned America. And we'll deliver that to you post-paid for $28 also. You will be amazed at this book. I'm just reading you a small portion of it. Very small portion. There are photographs in here that are official NASA photographs that will just blow your mind away once you have been educated. You can look at them yourself and tell that they're fake. And then you can go to the library and start pulling the NASA publications that they printed themselves off the shelves, and you can go through them and identify almost every single photograph that you're looking at as fake, and you can do it yourself with no spectacular education. It's really easy, and it will blow your mind. It will literally blow your mind at how we have been deceived. Not just deceived, but we've made fools of ourselves because the lies are so blatantly obvious once you begin to look for them that you're going to be ashamed of yourself. Now let's get back to NASA Mooned America by Renee. We're going to start talking about the limbs problems. The limb, the limb is well, you know what it is, don't you? At the start of the Apollo program, Joe Shea, NASA's chief administrator, decided the Apollo capsules should rotate about their longitudinal axis to keep the heat shield warm enough not to crack on re-entry. They called this passive thermal control, or PTC. Since the heat shield was covered by the service module until minutes before re-entry, I have no idea what they are talking about. Of itself, the rotation could neither heat the ship nor cool it. Maybe you've had the same experience. If you roast a whole chicken on a grill, folks, it doesn't matter whether the skewered chicken is rotated 5 times an hour or 50 times an hour. The chicken still cooks in exactly the same length of time, no different in space. The only thing that turning on a spit accomplishes is to cook the meat evenly. On a spaceship, axial rotation would distribute solar heat evenly, allowing the sun side and shade side hull temperatures to be fairly equal as long as the ship wasn't pointed directly at or away from the sun. But it would also greatly complicate the navigation. Not that the roll itself would be hard to compensate for, but at the time, the IMU, or Inertial Measuring Unit, and its associated computer would have had to cope with more than one set of problems at a time. Now, folks, this was when computer memory was so small and computer operating speeds were so slow that most people today familiar with a regular PC computer wouldn't even call these things computers. Indeed, Borman speaks of this twisting mode and says, quote, "We were using passive thermal control, PTC, which involved turning Apollo 8 on its long axis facing the sun and then doing a slow roll." Now, folks, here is a man who earned a master's in engineering from California Institute of Technology and went on to teach thermodynamics at West Point Military Academy. Yet he seems ignorant of the fact that once the long axis, that's the nose or tail, is pointed directly at the sun, the heat absorption is at a minimum so that the entire sun side of the surface will be evenly heated. Why would anyone bother to rotate the ship since the ship pointed at the sun and rotation would do nothing at all? It took the Apollo ships about 90 hours to travel to the moon and almost as long to return to Earth. During these periods of time, NASA claimed both capsule and service module were air-conditioned using power from the service module's fuel cells and other equipment mounted there. Now, to evaluate this system would require that NASA supply technical information about those systems, which unfortunately they will not. Even though the charter says all scientific information and developments and research will be made available to the public. Nothing will be kept secret. NASA has violated its own charter and is keeping, as you know, if you've tried to get anything out of NASA, an awful lot of information secret. Now, even though they won't give that information, we don't have such a problem with the awkward, unbalanced lunar landing module, or LEM. This pile of tin was so fragile, it couldn't support itself here on Earth and exploded whenever tested in our atmosphere. In fact, it had a perfect record of disaster until it was used on the moon. And then 8 times in a row, it worked perfectly, every time by landing safely on the moon's sunny surface. The moon is a 2-week day and a 2-week night. The first mission, Apollo 11, set down when the sun was only 10 degrees above the horizon, ostensibly to avoid the heat of the noonday sun. Later, Apollo landings took place later in the lunar day, and to add to the heat problem, all the landings were within 20 degrees of the lunar equator. Now, Mr. Noble has this to say about temperatures on the moon, quote, "Surface temperatures range from about 243 degrees above 0 Fahrenheit in the unfiltered sunlight at lunar midday to about 279 degrees below 0 in the depths of the lunar night," end quote. Now, this figure must be substantially correct. If it wasn't, wouldn't the astronauts have reported it? This is hotter than boiling water. In fact, this is hotter than the pressurized water in most household hot water heaters and boilers. And it doesn't say this in NASA Moon America, but 279 degrees below 0 Fahrenheit is so cold, ladies and gentlemen, that anything exposed to it would immediately become so brittle that if it were just barely contacted by something else that was hard, it would shatter into a million pieces, including arms, legs, aluminum, control consoles, landing legs, you name it. If you don't believe that, get some liquid helium, ladies and gentlemen, and take a rod of the hardest steel that you can find in there. Leave it in there for just a few seconds, take it out, and just barely tap it. Just barely tap it against something hard and watch it shatter. Now, over and over again, NASA preaches the cold of space doctrine. When Aldrin and Armstrong were sleeping on the moon during the Apollo 11 mission, Mr. Hurt wrote this, quote, Aldrin tried to curl up on the floor of the limb, only to discover that he was too elated and also too cold to sleep during the astronauts' scheduled 7-hour rest period before lunar takeoff. As he reported afterward, the thing which really kept us awake was the temperature. It was very chilly in there. After about 3 hours, it became unbearable. We had the liquid cooling system in operation in our suits, of course, and we tried to get comfortable by turning the water circulation down to a minimum. That didn't help much. We turned the temperature control on our oxygen system up to the maximum. That didn't have much effect either. We could have raised the window shades and let the light in to warm us, but that would have destroyed any remaining possibility of sleeping, end quote. Oh, really? Never stopped any of those women movie stars whose pictures you always see sleeping in the daylight with their little eye coverings over their eyes. Did NASA fail to make a system that could be turned off? Despite Aldrin's reported claim, the suit's cooling system cannot work in a pressurized cabin, as you will see in the next section of the book. In his book, all Aldrin has to say about that day is, quote, we didn't sleep much at all. Among other things, we were elated and also cold, end quote. Now, all of this seems very mysterious, since all the moon landings took place during the lunar day. That's when the surface of the moon is literally as hot as hell. If it's 273 degrees at midday, wouldn't the surface be at least 200 degrees when the sun is at 10 degrees? Remember, on the moon, that the sun has been rising for over 24 Earth hours to get that high. Isn't it reasonable to assume that the sun will heat every object on the moon's surface to roughly the same temperature? Remember, there's no atmosphere, they tell us. You see, if we can't believe what we know they've told us, how can we believe anything that they tell us? I mean, how can we believe them anymore? Does the sun not heat cars, houses, and pavements here on Earth? Have you ever picked up a metal tool left lying in the summer sun? It can raise blisters on your hand if you don't have on a glove. Is the sunlight on the moon different than that on Earth? Yes, ladies and gentlemen, it is. It is more intense since it isn't diffused by an atmosphere as on Earth. That's why noonday temperatures are hotter than here. With the sun beating down on the limb, how could it have been cold in there? How could it have? And why did he lie about having his suit air conditioner on, when the suits were designed to operate their air conditioner in a vacuum and not to work at all in a pressurized environment? And as far as not being able to sleep in the sunlight, only vampires have that problem. You see, normal people often fall asleep on sand beaches and lawn chairs in full sunlight. Isn't that why God made eyelids? Or why man created sunglasses and eye masks? Betty Davis knew how to do that. How come these guys didn't? How come Buzz Aldrin and Neil Armstrong didn't know how to close their eyes or put something over their eyes so that they could sleep if they had to open the sunshade on their windows? But you see, if the sun was beating down upon the metal of that lunar lander on the surface of the moon at 273 degrees, or let's give them a break. Let's say it was only 200 degrees. Heck, let's say it's only 175 degrees. Ladies and gentlemen, it would not have been cold in there. You see, I've seen those things. I've been to, and this is not in the book. This is my own experience. I've been to the Space Museum. I've been to the Smithsonian Institute. I've been to Houston. I have seen the limb. I have seen it, ladies and gentlemen. The thickness of the wall separating the outside from the inside of the limb is so thin, ladies and gentlemen, there is not an insulator on the face of this earth that could have kept the heat of the sun out of there. Now, if you don't believe me, you go and find the state-of-the-art of all insulating materials and find out exactly how thick an insulator you would have to maintain a normal temperature inside against a sun radiation hitting the outside of 200 degrees or more. Check it out for yourself. And then see how long that thing was sitting up there. And then go and look at it yourself and see how thin the walls of that thing are. And you'll see, in fact, if you're like me, you'll bust out laughing right on the spot. And somebody will look at you crazy. Only you won't be the crazy one. You'll probably be the only sane person there. When speaking about wearing a spacesuit, we're back to the book now, Collins had this to say, quote, "The astronaut would dissolve in a pool of sweat were there not some way to keep him cooled," end quote. Well, that's an understatement. The astronaut, as a matter of fact, would roast just like a hot dog in heat like that. But undoubtedly, he was speaking about a conditioned internal environment. Doesn't that mean the suits acted as insulation? Well, of course they did. Any suit will give some insulation, but these were supposedly manufactured to protect these astronauts against the tremendous heat of the sun and the tremendous cold of the vacuum of space, the cold that we know does not exist, but we know that the radiant heat conducted by electromagnetic rays does absolutely exist. That's how the heat of the sun gets through space to this earth. So obviously this entire story was scripted by the NASA space opera writers trying to obfuscate the fact that NASA claims that the limb's cooling system could only cool the electronics. That system, if it ever existed, operated on batteries. Yet there was no way shown to power the additional drain of an air conditioning system. Had it been present, Murray and Cox write this, quote, "Because the limb used batteries instead of fuel cells, oxygen didn't figure in the calculations about power supplies," end quote. Now, thinking about it, electronic equipment turns almost all the input power into heat. I don't believe the limb system as described could ever cool that, in addition to the radiant heat of the sun hitting the outside of that vehicle constantly, warming, heating at these unbelievable temperatures. Now, don't pay any attention to this, sun was at 10 degrees or 20 degrees or straight overhead baloney. In the vacuum of space, ladies and gentlemen, the radiant heat of the sun, no matter at which angle the sun is according to the moon's horizon, is no different than if the vehicle were out in the middle of space nowhere near the moon. Make sure that you understand that. During the Apollo 13 mission, NASA tells us about an explosion in an oxygen tank which bled out the other tanks, thereby depriving the fuel cells of the needed oxidizer. Now, this left the astronauts totally dependent upon the limb's batteries. As Murray and Cox report, quote, "Bit by bit, the limb was powered down to 15 amps per hour, and the astronauts, wearing thin clothing designed for a long trip in a confined space at 70 degrees, began to get cold as the temperature dropped below 60 degrees and kept going down, end quote. A prelude to this exciting story occurred on the Gemini 5 mission launched August 21, 1965, with astronauts Pete Conrad and Gordon Cooper on board. The fuel cells had an oxygen pressure reduction that went from 800 down to 120 psi. They powered down, which meant they turned off the capsule's air conditioner. It fell to 55 psi on the next orbit, and then, quote, the miracle happened. The pressure began to stabilize, though at a very low level, end quote. It was later determined that the fuel cell heaters had failed, and then the sun's radiant heat had begun to warm the cells. Wasn't the sun shining for the first 3 orbits? On that same page, we find Cooper and Conrad complaining to ground control that it was still too cold in the capsule. Quote, we've been sitting here shivering for the last few hours. How can that be? For folks, the capsule in space truly is a hot dog on a spit. It absorbs heat, the radiant heat of the sun. It cannot give off heat, for there are no molecules in space to accept the heat given off. And heat cannot travel except through molecular action. Are you beginning to get the picture? Are you beginning to understand how these people have conned us for so many years? Isn't this amazing? During Gemini 7, Frank Borman complained that the suit was too warm and that, quote, the cabin remained warmer than we wanted, end quote. Same limb. This was after they had turned down the cabin heat to as low a setting as possible. First question, why didn't Borman, the man who taught thermodynamics, insist on a simple on-off switch to the heat? Have you ever seen a vehicle where it was impossible to turn off the heat? The heat certainly had to be electrical. Why wasn't there a simple switch? Second question, why didn't NASA use common thermostats such as we use in houses and cars? Third question, how could this capsule get so warm when it spent half its time in the Earth's shadow while the Apollo 13 got so cold, spending all its time in the direct sunlight? Answer me those questions, ladies and gentlemen. NASA cannot and will not. So let's review what NASA claims. On the pad, the entire ship is air-conditioned by conventional air conditioning powered from the ground at Kennedy. The entire ship is air-conditioned in space, powered by fuel cells until you lose power to run the air conditioning system. Because you turned off the air conditioner, the ship gets colder. Oh, what fools we mortals be. Good night, ladies and gentlemen, and God bless each and every single one of you. And may you wake up tonight with a light bulb going off in your head. You can purchase a copy of this book, NASA Mooned America, by Renee, by sending $28 post-paid to Harvest, P.O. Box 2470, Pine Top, Arizona, 85935.
go. I'll feel happy as you go.
This is the voice of freedom.